notes to help you as you are taking your Chapter 3 test in statistics. So the first question asks us to find the range of some sample data. And the range is simply the highest number minus the smallest number. However, there is an easy and accurate way to do this without having to use a calculator. You can click on the data icon in the right corner and then choose Open in StatCrunch. Then choose Summary Stats and Columns. Then click on the column that you want to calculate the values for. Then click Compute. And it says that the range is 9. As you can tell by looking at the numbers, and the highest number is 10 and the lowest number is 1. 10 minus 1 equals 9. So the range is 9. The standard deviation, it also shows that right here. It is that number. But they want us to round it off to just one decimal place, so it rounds down to 3.0, or you could also just say 3, because 3.0 is the same as 3. The variance is 9.27, which rounds off to 9.3. Can these results be used to describe the variation among attractiveness ratings for the population of adult males? Well, I didn't actually even look at the problem. Let's just see. It probably sounds like it's a study, so people probably had volunteered to do it. So since it's likely that the male subjects volunteered to participate, they may not be representative of all adult males, so the results cannot be used to describe the population. So once again, I'm going to click on the data icon and choose Open in StatCrunch. And the coefficient of variation is a good way of comparing the variation between samples. It's just the standard deviation divided by the mean of the sample. So let's do that real quick. Stats, calculators. Stats, summary stats, columns. So hold down the Shift key and click on both columns. And then go down here, don't click compute yet. You need to do other statistic. So do STD of x divided by mean of x. And so it's STD open parentheses x close parentheses divided, which is like a slash, divided by MEAN parentheses open parentheses x close parentheses. Then click compute. So the coefficient of variation for the security service company is this thing we calculated right there, that number, standard deviation divided by the mean. Except we have to change that to a percentage and then use one decimal place. So if we move the decimal point over to right there instead of right there, and then take off the leading 0, it's 9.28, which rounds off to 9.3. Then once again for the other companies, that number is this, which I'll just do this right now in my head. It's 0.073, which would be 7.3%. And so that's that. Do they show any evidence of stealing by the security service company's employees? Well, there is a difference bigger than 1%, and it says that's significant. So yes, because there is a significant difference in the variation. Okay, the range rule of thumb is that the range typically tends to be close to 4 standard deviations. And 2 of those are above the mean and 2 of them are below the mean. So if this is similar to a typical example, then it would be, okay, so the low value normally would be close to the mean minus 2 times the standard deviation. So that would equal it's kind of hard to see these numbers. .48 is the mean minus 2 times 1.44, and that gives you 25.6. 28.48 minus 2 times 1.44 is 25.6. So 25.6 or lower would be significantly lower because it would be lower than a normal type of situation. Okay, in a normal type of situation, the range is about 4 standard deviations roughly. So if you took the mean plus 2 standard deviations, that would typically be the largest ordinary type of value. So we'll take the mean of 28.48 plus 2 times the standard deviation of 1.44, and we'll get 31.36. And then, so let's see. Then the next part of the question says, is the adult male foot length of 32 centimeters significantly low or significantly high? Well, 32 is a little bit more than the normal highest value. So I would say a male foot length of 32 is significantly high. So I'll choose part B because it is greater than, the reason it's high is because it's greater than 31.36, which is normally what would be the highest normal high value. Okay, then here's a tip that I've already put for you on this problem. 68% of data distributed normally are within the mean plus or minus 1 times the standard deviation. 95% are within the mean plus or minus 2, and 99.7% of data are usually within the mean plus or minus 3 times the standard deviation for normally distributed data. So, in this case, what's the approximate percentage of women with platelet counts within 3 standard deviations of the mean? Well, according to that rule of thumb that I just told you about, 99.7% of the women would have values within 3 standard deviations of the mean. The next question is a little bit harder because we have to calculate something. So let's just do the mean of 261.6 minus 2 times the standard deviation, which is 65.8. So 261.6 minus 2 times 65.8, and that's 130. And then let's do 261.6 plus 2 times 65.8, and then we get 393.2. So you notice that those two numbers that they give us, I wasn't sure if they were, but they're exactly 2 standard deviations lower. So you can see 2 standard deviations lower than average and 2 standard deviations higher than average. So as we mentioned, 95% of the values tend to be between 2 standard deviations lower and higher than average. So that's going to be that result. Okay, then this problem says a successful basketball player has a height of 6 feet 3 inches or 191 centimeters. And by the way, these numbers are randomized, so whenever you see something in on your statistics homework that says something like a successful basketball player has a height of such and such, that's not necessarily an actual fact. So there could be successful players that have a different height. But anyway, so according to this problem, the height would be 191 centimeters. So based on the statistics from a data set, his height converts to a z-score of 2.31. How many standard deviations is his height above the mean? Well, the interesting thing is a z-score literally is how many standard deviations something is compared to the mean. So if it's positive, then that's how many standard deviations it is above the mean. So the player's height is exactly 2.31 standard deviations above the mean. Okay, if you score on your next statistics test, which would you prefer? A z-score of -2, -1, and so forth? Well, obviously the highest z-score is preferable because a z-score of 0 means that you scored the same as average. A negative z-score always means you're below average, and a positive z-score always means you're above average. And by the way, in statistics, the word mean means the same as the word that we normally say in English of average. So this means a negative z-score means you scored below the mean, 0 means you scored the same as the mean, and a positive z-score means you scored above the mean. But a z-score of 2 means you scored as high above the mean, the highest above the mean out of those 5 options. So the z-score of positive 2.0 is the most preferable because it's 2 standard deviations above the mean, and it's the highest of the 5 possible test scores. Okay. So this one says, what's the difference between the pulse rate of 31 beats per minute, 31, minus the mean pulse rate of females, which is right here. The mean, it says, is 74. So 31 minus 74, that's -43. 31 minus 74 equals -43. And so now, how many standard deviations is that? Well, the number 43 divided by the standard deviation, which is 28.5. 43 divided by 28.5 is 1, and it says 2 decimal places, so 1.508. That rounds up to 1.51. And then the z-score is, okay, now notice that the difference is a negative difference. So the actual z-score is negative because it's below the mean. So any number below the mean always has a negative z-score. And the value of the z-score is the actual difference between that number and the standard deviation divided by the standard deviations. So we already know how many standard deviations it is. We just need to make it negative in order to get the z-score. So the z-score is -1.51. And then the lowest pulse rate, let's see. So the lowest pulse rate, it says, is 31 beats per minute. But this 31 beats per minute only has a z-score of -1.51. And so that's between -2 and 2, so that's considered normal. That is not significant. So this is a similar problem. Anything with a z-score less than or equal to -2 is significantly low, and it's significantly high if it's a z-score greater than or equal to 2. So let's see if we can figure this out. The mean is 5.74769. 5.74769. And if I subtract 2 times the standard deviation, which is 0.05, which is just see. Which is 0.05151. 5.74769 minus 2 times 0.05151. Okay, so that means that 2 standard deviations less than average, 5.74769, works out to be this number right here. So it wants 5 decimal places of accuracy, so 5.64467. So significantly low would be weights that are less than that. Okay, then if I do the mean 5.74769 plus 2 times the standard deviation, then I get that number. So anything that is greater than that number is significantly high. Okay, now it says use the z-scores to compare the given values. So z-score is defined as being equal to the the z-score of a number is the number itself. So let's see, the number of the male is, the male, it says, weighs 1,700 grams. So the z-score of that baby, of that newborn, is its value, 1,700 grams, minus the mean of the newborn males. The mean value for newborn males is 3266.1, divided by the standard deviation of newborn males, which is 738.1. And so the z-score for the male, rounded to 2 decimal places, would be negative 2.12. Negative 2.12. Negative 2.12. Then the z-score for the female. Okay, so the z-score for the female is equal to, okay, the female also weighs 1,700 grams. So her z-score would be 1,700 minus the mean, but this time it's the mean of the females. So it says newborn females have weights with a mean of 3024.2. 1,700 minus 3024.2 divided by the standard deviation of females, which is 478.9. 478.9. So this z value is negative 2.765, which rounds off to negative 2.77. So negative 2.77. And since negative 2.77 is further from 0, that is a more significant and more extreme value. So the female has a weight that is more extreme. And since these are both negative, that means they're both less than average. So this baby weighs less than average, and this baby weighs even a more significant amount less than average. Okay, so this says find the percentile corresponding to the data speed 10.8. So let's click on the data icon, click open in StatCrunch. Okay, so notice there are exactly 50 numbers that I gave you in this problem, 50 of them. Now and they're sorted in order already, which is really helpful. So let's find the number 10.8. That's the 43rd number. And so if you think about it, the 43rd number out of 50, if you think about 100, that would be the, okay, what's 43 times 2? 86. That would be the 86th number out of 100. So this number is equal to the 86th percentile. Okay. Alright, then here we're making a box plot. So a box plot, you find the median number first, which you sort the number in order, and then you find the very middle number. Then, once you know that very middle number, then you look at the lowest number and the highest number. That would be the minimum and the maximum. And then you find the middle number of the bottom half of the data and the middle number of the top half of the data. That's called the first quartile and the third quartile. And guess what? You can have, if you click the data icon and click open in StatCrunch, you can have StatCrunch calculate all those numbers for you. So let's do stat, summary stats columns, click on that variable, then click compute. So you can see right here that the minimum is 3. So let's just see, the minimum is 3. The maximum is 10. That goes last. Then the median is the middle number, that's 7. Then the middle of the first half of the data, that's called Q1, that's 6. And then the middle of the second half of the data is called Q3, and that's 8. So those are those 5 numbers. Then what a box plot is it's a number that shows the median, 7, and then a little box going from 6 to 8. So we can make that with this program if we want to. Or we could probably even tell which one it is just by looking. So 7 is right there, so it could be that one. That one right there is not, that line in the middle is not at 7, so it cannot be B. Okay, this line is at 6, so it could not be 6. And this line is at 7, so it could be either A or it could be D. Now let's look at Q1, 6. So the bottom edge of this box needs to be exactly at 6. So the middle needs to be at 7, and the bottom of the box needs to be at 6. So this is a 7, and that's a 6. This one is a 7, but that bottom edge is not at 6. So the only possible answer could be A. And by the way, let's look at the rest of it. See, the top edge of this box in A is at 8, and then it goes to 10, and then it goes down to 3. Now, if you had, there is something called outliers. If you had an outlier, then you would put a little star or an asterisk at the outlier, if there were one, but there isn't on this problem. So that's all. And so those are some notes to help you as you're taking your Chapter 3 test.